Hello, hello, hello. We're going to do 189 and 190. Let's take a look. A group of 8 people work on the 5th floor of a building. They all decide they want to lose weight by increasing their physical activity. 4 of them. So we got 8 people. 4 decide to do one thing. 4 decide to do another. So it says 4 of them decide to walk up 5 flights of stairs each workday. The other 4 decide to walk down 5 flights of stairs. Now, right off the bat, we typically have to have random assignment here. And notice we don't have that. So it says they weigh themselves each Monday morning and report their weight to their supervisor. So basically we can compare the results, and the results are going to be crappy because we didn't do random assignments. So what happens when we don't do random assignments is the issue here is it's ultimately an observational study, even though it looks like I mapped it out. We're merely able to just observe after the fact because the supervisor didn't decide which group would walk up or would walk down. So we don't really know which one has more of a benefit, walking up or walking down. So some other things to kind of consider that you always want to be considering if you're choosing which group you want to be in. You have to be careful because people that decide to walk up might also decide somewhere else in their day to do other things that might improve their weight loss. For instance, a person that has a choice, okay, I could walk up five flights or down five flights. The person that chooses to take on maybe a harder task might also be more likely to park further away, choose to take the stairs in their apartment complex, might choose to try to keep walking once they get home till they get 10,000 steps. They also might try to eat less than 3,000 calories a day. And so all these other reasons could be the real reason why they're getting good results. And so that's why we have to have random assignment in order really to be able to compare, and we don't have that here. So again, we're definitely circling B, and that's the example of what is happening there. Now let's take a look at 190. We got a regular little box plot, or excuse me, histogram, and they've made these little boxes here for us. So we want to fill that in with those values. So it looks here as if the histogram represents yield of 20 apple orchards in the area. Okay, so it looks like 4 of them have a yield under 20. 3 of them have a yield just under 40, above 20 but under 40. 8 have a yield between, it's kind of hard to see this, so I'm just gonna rewrite this. 8 between 40 and just under 60. The next 3, the next 2. So again, if I add these all up just to be positively sure, I get definitely 20. Okay. So now it says, what proportion of these orchards exceed 20 bushels? So it looks as if the bars that exceed 60 bushels would be these 2. So that would be, we don't know what the names of them, but we know 5 of the orchards are exceeding 60 out of a total of 20. And so how did I get 5? It looks as if I added the 3 and the 2 out of a total of 20, and I got 1/4, which would be the fraction D, 0.25. Thanks for joining us.